Hi everybody, so this is part 2 of working with rational expressions. We're going to talk about adding and subtracting rational expressions. So before we do anything else, let's talk about the method. Okay, and it's the same for both adding and subtracting. Okay, so the first thing you really want to do is find the lowest common denominator, right? That's what you would do with numerical fractions, but to do that, what we're going to do is factor all the denominators. Okay, and then that's going to help us find the LCD. Okay, so after we know the LCD, we're going to change so that every single fraction has that LCD. Okay, and then we're going to combine like terms in the numerator. Okay, and then the last thing we're going to do is simplify if you can. Okay, all right, so we already know how to simplify, by the way. That's what we talked about in the first part of the last video. So if you haven't seen that, you should really watch that one first. Okay, so let's do an example first of just finding the LCD. Okay, so these are just numerical fractions. You guys should be able to find the LCD. I just wanted to point out that when you have two fractions like this that have a common factor, these two have a common factor of 6, you don't just multiply them together, right? You just take, right, this has a factor of 6, this has a factor of 6 and 2, okay? So when you're looking for the LCD, you don't multiply these two and say, oh, this is 36 times 2, right? You just do one copy of the 6 times 2, which is 12. Okay, so you guys already know that, but I just want to relate that to what we're going to do with the polynomial factors. Okay, so if you have something where the denominators have nothing in common, like these two, that's when you do multiply them together. Okay, so for this example, it would be 6x. Another example like that, okay, if you have these two things, these have no common factors, so to find the LCD, you just multiply them together. Like that. Okay, all right, so let's do some ones where we actually have to do some factoring. Okay, so the first thing we're going to do, like I suggested, is we're going to factor the denominator here. This factor's already done. Okay, and then for the LCD, right, we're going to list each unique factor. Okay, so they have a shared factor of x plus 2, so I'm going to put that. Okay, and you have a factor of x minus 3, so I'll also put that. Okay, it doesn't matter what order you put them in. You could also write this like x plus 2, x minus 3. Doesn't matter at all. Okay, all right. Let's do a couple more like that. Okay, so we're going to factor each of these. Okay, so there's our factors. So then to find the LCD, we're going to include all of the factors. So we'll have x minus 3, x minus 2. You don't need to repeat this because there's only one in each of them. Okay, and then x minus 1. All right, last one of these examples. We're going kind of quick through this because you guys should have already seen this in your Algebra 1 class, so this is just a little refresher. Okay, so this is a unique case where you do have two of the same factor in the same fraction, okay? So in this case, you really do need both of them as part of the LCD, okay? So the reason for this, right, is that the LCD is something that you're building up to, right? You're going to multiply by something to get this. Well, you can't really multiply by something to get rid of one, right? You would have to divide. Here you can multiply by something to add one in, okay? So that's why you're taking the bigger of the two, right? Or the more copies of that same factor, okay? It's the same reason that if you have 1/2 and 1/4, the LCD is 1/4, or is 4, sorry. All right, so let's do some examples where we're actually adding. Okay. Okay, so the first thing we're going to do is find our LCD. Now, as much as these look alike, they don't actually have any common factors. So to find the LCD, we're just going to multiply them together. Okay, they have a common term. That's not the same as a common factor. Okay, so to get my LCD here, I'm missing x minus 1. So I'm going to multiply by x minus 1 over x minus 1. Okay, and here I'm missing my x, so I'm going to multiply by x over x. Okay, so let's multiply that out. So 5 times x is 5x. 5 times -1 is -5. Okay, now in the denominator, I don't necessarily need to multiply it out, and I'll tell you why. It's because you're not going to add the denominators, right? You're multiplying it out in the numerator because you are going to add the numerators together. You're never adding the denominator, so you really don't need to multiply this out. Okay, so here I would have 3 times x, which is 3x, over x times x minus 1. Okay, so now that I do have common denominators, I can add the numerators. So 5x plus 3x is 8x minus 5 over x times x minus 1. Okay, now if this factors, you should factor it and try to simplify, but it doesn't factor. Okay, so that means this would be our final answer. All right, let's look at some more examples. Okay, so in order to find the LCD, I'm going to factor both of these denominators. Okay, so I can tell for my LCD that for the numerical part, 3 and 5, it's going to be 15. Okay, and then for the other part, they share a factor of x minus 2. Okay, remember you don't need to repeat that factor unless there's 2 here in the same fraction or 2 here in the same fraction. Okay, so if I want this to be 15x minus 2, I need to multiply by 3. And here, if I want this to be 15 times x minus 2, I need to multiply by 5. Okay, so here I'm going to multiply it out. Okay, again, you don't need to multiply this out because you're not going to be adding that with anything. Okay, and now I'm going to subtract. 21 minus 25 is -4. over 15 times x minus 2. Okay. Now there's no common factors between that 4 and that 15, so this is my final answer. All right, let's move on to some more difficult examples. Okay. Okay, so the first thing I'm going to do is factor the denominators so that I can get the LCD. Okay, so looking at those 4 factors, right, I have this repeated factor of x minus 4, so my LCD is going to be x minus 4 times x minus 3 times x plus 2. Okay, remember you have to include all the factors because you can only build up to the LCD. You can't take anything away. Okay, so here from my LCD, I'm missing the x plus 2, so I'm going to multiply by x plus 2. And over here, I'm missing the x minus 3, so I'm going to multiply by x minus 3. Okay, so let's multiply. Negative 1 times x is negative x. Negative 1 times 2 is negative 2 over my LCD. Okay, 6 times x is 6x. 6 times 3 is 18 over my LCD. Okay. All right. Now the last thing I'm going to do is combine like terms. So I should get 5x, and then minus 2 is minus 20 over x plus 2 times x minus 4 times x minus 3. Okay. So now you can see that this numerator does factor because it has a common factor of 5. So I'm going to factor that out. Okay, and this is why we do that, because you can see now these have a common factor and I can actually simplify my solution. Okay, and that's my final answer. All right, so let's do some more difficult examples. Okay, so again, I'm going to start by factoring the denominator. This one factors, that one's already factored. Okay, and now my LCD, I'm going to include all of my factors. So I'll have y plus 1 and y minus 1. Okay. Now here I already have the LCD, so I don't need to multiply by anything. Here I'm missing the y minus 1, so I'm going to multiply by y minus 1. Okay, so this is going to stay the same. Okay, 5 times y is 5y. Okay, 5 times negative 1 is negative 5. Okay, so now I'm going to subtract. Okay, so remember this negative sign affects both of these. Okay, so I'm going to have 1 minus negative 5, which is the same as 1 plus 5, or 6. Okay, and then I'm going to have negative 5y. Okay, as you can see for this one, this doesn't factor at all, so that means we must be done. Okay, it's really important that you remember this negative sign affects both terms, right? And this is a super common mistake that I see. People will put negative 5y, but then they'll forget they're subtracting and just do 1 minus 5 is negative 4. Okay, so remember you're doing 1 minus negative 5. All right. Let's see one where there's a something that isn't a fraction. Okay. So remember, whenever you have something that isn't a fraction, you can always put it over 1 to make it a fraction. Okay. Now when you're looking here, there's really only one denominator, so it should be clear that the common denominator is y. Okay. So to get that denominator here, I'm going to multiply by y. This one already has the common denominator. Okay. Now, this is an interesting example because there's really no way to combine these two. So the only thing you can do is write this as a single fraction. You can't combine, right, the y and the 1 because they're unlike terms. So all you can do is rewrite it as y plus 1 over your common denominator. Okay, let's look at one more with something that isn't a fraction. Okay, so I'm going to factor this in hopes of finding an LCD, and I'm going to turn this into a fraction. Okay, so now that I can see all my factors, my LCD is x plus 2, x minus 2. Okay, and so here I'm missing everything from my LCD, so I'm going to multiply by the whole thing, x plus 2, x minus 2, and I'm going to do the same thing in the denominator. Okay, here I already have the LCD, so I'm going to leave that, and here I'm just missing the x minus 2. Okay, now I want to multiply this out. Okay, so I'm going to multiply all three of these together. Okay, so just remember, right, as an aside, that x plus 2, x minus 2 times x, this is what we're doing. So we know what this is. This is x squared minus 4. That's how we got here. Okay, and then we're multiplying by x. That'll give us x cubed minus 4x. Okay, so that's why I'm going to write that here. I'll write x cubed minus 4x over x plus 2, x minus 2. Okay, now here I already have my common denominator. Not doing anything to that fraction. And here I'm also going to multiply it out. Okay, so I have 3 times x minus 2, so that'll be 3x minus 6 over my common denominator. Okay, and now I'm going to combine all my like terms. So there's no like term for the x cubed. Okay, now I have negative 4x and 3x. That'll be minus 1x. Okay, and then for the numerical values, I have negative 2 and negative 6, so that's negative 8. Okay, now because this is x cubed instead of x squared, you know that this doesn't factor. So I would leave my answer just like this. All right. So I hope that reminds you guys how to add and subtract fractions and about getting common denominators. Okay. If you have any questions, make sure that you get them answered because this is a topic that you're supposed to have already seen. Okay, so let's talk about complex fractions. Okay, which are also sometimes called compound fractions. Okay. Now, a complex fraction, let's say what this is. Okay, so a compound fraction is any fraction where the numerator of that fraction, the denominator of that fraction, or both of them have a fraction in them. Okay, so an example, one that comes up a lot would be like 1/1/2. Okay, that's an example of a compound fraction. You could also have something more complicated like 1 plus 1/x over x plus 1. Okay, or if they both have a fraction, you might have something like this. Okay, so all of these are examples of compound or complex fractions. Okay, I normally say compound fractions just because complex has a connotation with complex numbers. All right, so let's talk about the mode for simplifying these. Okay. Now this isn't the only way to simplify them, but to me, this is by far the easiest and the fastest way to simplify a compound fraction. So the first thing you want to do is find the LCD of the small fractions. Okay, so what I mean by that, like in this example, that would be 1/2. In this example, it would be 1/x. Here it would be this fraction and this one. Okay, but the ones that are not the big fraction, but the much smaller ones. Okay, once you do that, you're going to multiply numerator and denominator by that LCD. Okay, now when this happens, there should be no small fractions left. Okay, so after that step, you should only have the bigger fraction. Okay, then you can simplify. Okay, if possible. Okay, sometimes that simplifies, sometimes it doesn't. All right, let's look at some examples. Okay, so here's our first example. Okay, so the only small fraction is this. Okay, which means that our LCD is going to be x. Okay, now I'm going to multiply in the numerator and the denominator by x. Okay, so x times x is x squared. X times -2 is -2x. Okay, and then I'm going to do the denominator. X times x is x squared. Okay, and then here, right, we're doing 4/x times x, right? So these are going to cancel, and I'm just going to get 4. Okay, so you can see what I mean about that canceling the denominators. If you picked the right LCD, it should cancel out all of your denominators and you'll just end up with one normal fraction. Okay, we do know how to simplify these. You factor everything, and then you cancel your common factors. Okay, so our final answer would be x over x plus 2. Okay, let's see another example like that. Okay, so you can see our smaller fractions. Here's one, and here's one. Okay, so our LCD, right, they share a common factor of a, but we also have this factor of 2, which we're going to include. So our LCD is going to be 2a. So I'm going to multiply here by 2a and in the denominator by 2a. Okay, now just for ease, I'm going to write it next to this. Okay, and I'm going to write it next to this so we can see what we're doing. Okay, so here this a is going to cancel with this one, and I'll have 2 times 2, which is 4. Okay, now here this 2 is canceling with this one, this a is canceling with this one, so I'm just left with my 3. Okay, in my denominator I have 2a times 5, that's 10a. Here this a is canceling with this one, and I just have 2. Okay, so the last thing I need to do is add these two together. Okay, and this would be my final answer. You're welcome to factor the denominator here, but I don't really feel the need to because I can tell it's not going to cancel with this. All right, let's see another example like that. Okay, so here's our two little fractions. This is an a, not a 9. Okay, so our LCD is going to be a squared. Okay, so I'm going to write a squared next to every single term so that I can see what I'm doing. Right, this is what happens when you distribute anyways, you end up multiplying every term. Okay, so a squared times 1 is a squared. Here, this a is canceling with one of those, so I'll get 2 times a, which is 2a. Here I get a squared times 1, that's a squared. And here, this a squared is canceling with this one. Okay, so I'm going to get minus 4. Okay, now I can't tell if this is going to simplify or not, so I'm going to go ahead and factor. Okay, the bottom is the difference of squares. Okay, and this does have common factors. So my simplified answer would be a over a minus 2. Okay, and it's important to remember that you can't cancel those a's. All right, so if this is a new method for you and you need more examples, feel free to come by the Zoom meeting. Okay, and otherwise, I hope this reminded you of how to simplify complex fractions and add them together. I'll see you guys soon.